Okay, YouTube, this is another video on solving exponential equations in which we're going to look at a special case in which we need to factor to solve this exponential equation. So, you know, as I say here, sometimes we'll benefit from factoring expressions. We're looking the expression that we're working with first before we solve it. This is a particular example of that. So we would say solving this, e to the 2x, I'm going to rewrite this, e to the 2x minus 8e to the x plus 7 is equal to 0. And so I know that this is not what you typically look at when you factor something, but this is something that is definitely factorable. And the way I kind of approach this is just to look at it this way. We say that this is really e to the x to the second minus 8 e to the x to the first plus 7 equals 0. And so recognizing this, even if I said let u equal e to the x, then what this expression would really look like is u squared minus 8u to the first plus 7 equals 0. So looking at it this way, what we could say is, well, it's a trinomial in quadratic form, and we're looking for two factors of a positive 7 that add up to be a negative 8. So I can think that these would have to be a u minus 7 and a u minus 1, but those would be multiplying out to a positive 7 to add up to be a negative 8, and this is what we end up with here. So one thing I want to do before we kind of finish this off is put our u value back in here. We said that u represented e to the x, so really what we have is e to the x minus 7 and e to the x minus 1 equaling 0. So I'm going to put a box around this, and I'm going to say that, you know, you do enough of these after a while, you don't need to do any u substitutions for this value right here. You can just recognize that this is in quadratic form, and I could say, well, you know, e to the x minus 7, e to the x minus 1, if I were to multiply that out, that gives me this expression right here. So because this times this equals 0, what we can do instead now, since we couldn't isolate the exponential base before because there we had two different bases, now what we can do is we could say, well, then either e to the x minus 7 equals 0 or e to the x minus 1 equals 0. So solving these, I suppose I'd add 7 to both sides. We get e to the x equals a positive 7. And then we'll take the natural log of both sides of this. So we get the ln of e to the x equals the ln of 7, which these cancel and just leave us x equals the ln of 7. And likewise, when we look at this over here, we're going to get e to the x equals 1. And taking the natural log of e to the x means we have to take the natural log of 1. But we end up with this here, x equals the ln of 1. So in this particular instance, I can tell you that, well, the log of 1 is always 0. So one of our solutions here is 0, and the other one is just the ln of 7, whatever that happens to be. We could find this out to two decimal places using our calculator here. So I suppose, let's go ahead and just type this in here. ln1, that was one of our values here. We get 0. But the ln of 7 would be about 1.95. So we say x is equal to 0. X is approximately equal to 1.95. But these are a solution and approximate solutions. Cheers.